Previous class we have discussed that in deadlock avoidance, our objective is to before allocating the resource, we must ensure that this allocation should not lead to put the process in the unsafe state, because if a process in the unsafe state, it may lead to deadlock. We do not give a guarantee that it is in deadlock, it may lead to deadlock. But we can give a guarantee that if it is in safe state, definitely deadlock will not occur. We have discussed this one. With this conclusion, we have done in the previous class. So for that, that is a slight changes in the resource allocation graph that we have read earlier. What we will do, whenever a process is requesting some resource, we'll put a claim edge. We'll put a claim edge, and we'll see that by putting that claim edge, whether it forms a cycle or not. So suppose this is requesting this resource. If I allocate, this forms a cycle. Although every cycle doesn't lead to deadlock, but there is a chance of deadlock. So we'll deny or will not allow the resource 2 to be allocated to process P1. Right? So from slightly changing the resource allocation graph by putting a claim edge. Before allocating, we'll make a dotted edge over here. Dotted edge is known as the claim edge. So we'll assume that if it will be given, then whether it is forming a cycle or not. If it is forming a cycle, that means it may lead to unsafe state. And if it is in unsafe state, there might be a chance of deadlock. Right? This we have read. So now in today's class, we have a very important algorithm. It's called the banker's algorithm. Very important algorithm over here. This is, do remember that banker's algorithm is used for deadlock avoidance. Deadlock avoidance. It is not for prevention. This is not for prevention. Banker's algorithm is used for deadlock avoidance. Similarly, the resource allocation graph that we have used by using the claim edge, it is also used for avoidance, deadlock avoidance. The banker's algorithm says that it's applicable to resource allocation with multiple instances of any type, right? So here we have a single instance actually. If it contains a single instance, then it may lead to deadlock. So banker's algorithm is used for multiple instance of any type. You can have any number of resources with multiple instance types. So before requesting any resource, each process must a priori claim maximum use. So every process will say what is the maximum use of their, how many type of resource they require. A process requests a resource, it may have to wait. Suppose a process makes a request, it has to wait till it is being allocated. So it is not immediately allocated. An algorithm will be run and then the resource will be allocated to the process. And when a process gets all its resources, it must return them in a finite amount of time. That means suppose a particular process P5 requires 10, suppose 5 hard disks, 3 has already allotted. Whenever the rest 2 will be given, he has to, the process has to return all the 5 hard disks. So whatever the resources it has priorly allocated, those resources also it has to return. Now question is that why it is a banker's algorithm? The way the banker gives loan to the customers, looking into that only this has been simulated. How the bank give loan to the people? It gives whatever the amount it has, it gives those amount to different people. They have different need. So it is not that the bank is giving all the amount at a time. Suppose you have requested for a 10 lakh loan. All the 10 lakh will not be given at a time. Maybe 3 lakh or 4 lakh will be given at the stage. Whenever the next installment, maybe after some time, the next one will be given. Whenever the bank will give all the amount to the customer, like 10 lakhs has been given to the particular customer, then with a hope that the customer will return all those amount it has previously have. That means all the 10 lakhs it will return. So it may be given in it may be the bank may be given to the customer in installment 4 lakh, then 4 lakh, then 2 lakh. But once the 10 lakh will the bank will give, because the maximum need of the customer has been satisfied. Now the customer has to return all the 10 lakhs. Similarly, a process may require some resource. A part of this may be given, but once its need is fulfilled, the process after completion its work, process must return all its resources that has been given to it. Correct? So looking into that only, the banker's algorithm. So it is not that one customer, there might be multiple customer will be there. And each of the customer has different need. Every customer is allocated with a part of their claim, and the rest part will be given by the bank. So bank must allocate the amount to these customers, those who are applying for loan, in such a way that the amount must be returned and all the customers' demand must be fulfilled. It is not that it will go on giving the amount to customer, and if it cannot fulfill the demand of any one of the customer, then what will happen? It will be in the state of deadlock. Right? We'll take an example to see that how it may lead to deadlock. Hello, any doubt over here till now?
No, sir.
Okay. Now, so for this banker's algorithm, we will use a data structure. So what is the data structure that is used for banker's algorithm? Data structure means what are the arrays or variables or what we take? We take some arrays over here, some one-dimensional and many two-dimensional arrays. N is the number of processes. M is the number of resource types. N is the number of processes. M is the number of resource types. Correct? N number of processes and M number of resource types are there. Suppose I will say there are 5 processes and 7 number of resources. Resource types. Resource types means maybe hard disks, memory, bus. These are all resource types. So available is a matrix, is a vector of length M. If available of J equals to K, that means there are K instances of resource type Rj are available. That means if I say available of hard disks is equal to 3, that means 3 number of hard disks are available. Available in the bracket hard disks equals to 3, that means 3 number of hard disks are available. Available of tape drive equals to 2, that means 2 number of tape drives are available. So available in the bracket is your what? Is the resource equals to the number of instances. So that means K instances of resource type Rj are available. Correct? It is a vector of, is a one-dimensional array. The max is a n cross m matrix. It's a two-dimensional. Max is a n cross m matrix. If I write max of ij equals to k, max of ij equals to k, that means the process Pi can request at most k number of instances of resource type Rj. The process Pi can request maximum of k number of instances of J type. That means suppose I'll write max of P5.
Sir, your voice is breaking.
This is maybe network problem. Okay, let me see that whether it's coming or not. Okay, if I say max of P5 comma hard disk equals to 3, that means process P5 has maximum requirement of 3 hard disks. I is the process, J is the resource, K is the number of instance. So a particular process can have maximum, what is the maximum need for a particular process? What is the maximum demand? So whenever a process will enter into the system, it will say that this is my maximum demand. So every process enter into the system must declare the maximum number of resources of which type is required. The next one is allocation. Allocation matrix is also a n cross m matrix. It's a two-dimensional array. So if I say allocation of ij equals to k, that means process pi is currently allocated k instances of rj. See, what is the difference between max and allocate? Let us give an example. If I say max of P1 comma hard disks, max of P1 comma hard disk equals to 5. Suppose I have written. So that means P1 process can have the maximum demand for P1 process is 5 hard disks. But if I say allocation of P1, if I say allocation of P1 comma hard disk equals to 2, that means out of 5, 2 are being allocated. If I say allocation of P1 this is equal to 2, suppose, that means the maximum need is 5. Now 2 are being allocated. So what is the need? If I need is also a n cross m matrix. If need of ij equals to k, that means if I say what is the need for P1 hard disks, then it will be how much? If P1 hard disk, then it is 3. That means need is equals to max minus allocation. Need is max minus allocation. Correct? So max is the maximum demand for a particular process, for a resource. Allocation is the maximum number of resources that are being currently allocated. Need is what is the need for that process currently, what is the need of that process. Do remember, a need cannot be more than this maximum max need that has been declared by the process. So these three are two-dimensional arrays. Max, allocation, and need are two-dimensional array. Available is a one-dimensional array. Add is a variable for number of processes. M is for number of resources. That you have to remember. This is the data structure that we will going to use in our bankers algorithm. We will solve a problem, and similar problems may come in your exam as well. So try to understand. So we have what? One matrix available, two-dimensional matrix max, allocation, and need. Is the matrices understood? Max, allocation, need, and available. Available is just a one-dimensional matrix like this. There are some, suppose I have 1, 2, 3, 4, 5 resources. This is resource 1, this is resource 2, like that it is there. Resource 1, resource 2, like that it is there. Resource 3, resource 4, resource 5. I have 5 resources. And some number over here, suppose 5, this is 2, this is 10, this is 7, this is 4. That means there are 5 number of instances of R1 type is available. There are 2 number of instances of R2 type is available. There are 4 number of instances of R5 type is available. Is it understood? Is the data structure understood or not? This will apply on the algorithm and will solve the problem on the same. Any doubt on this? Okay. Let x and y are vectors of length m. If x is less than y, if only if x of I is less than, when I say x is less than y, that means each element of x must be less than each element of this y. That means x of I less than y of I, x of 1 less than y of 1, x of 2 less than y of 2. So that we are using over here. If x and y are two vector length n, and we are comparing x and y and we are saying x is less than y, that means x of I should be less than equals to y of I. Just look over here. Suppose this is x, 3, 2, 5, and y is 5, 4, 5. See, each element, 3 is less than 5, 2 is less than 4, 5 is, if the corresponding elements are less, then I can say x is less than y. Correct? So allocation of I specifies ith row of allocation matrix and is treated as one vector. It specifies the resources currently allocated to process Pi. And need is additional resources process Pi still requires. So anyway, you just remember these things. These are very, very important. The previous slide, what I said, resources, available, max, allocation, and need. Correct? This is the resource request algorithm. I will explain you this resource request algorithm, but before that, I'll solve a problem so that you will understood that how the problem is being solved. Then we can relate that how this algorithm is being written. Algorithm is very simple. It's not very difficult to understand. I will tell you that algorithm, but once the problem will be solved, it will be easier for you to understand. So we have two algorithms over here. One is resource request algorithm, another is safety algorithm. But I will go to this problem now. Only look into this, look on the right hand side. Look into this right hand side. Let us suppose 5 processes are given. P0, P1, P2, P3, P4. So I have 5 processes P0 to P4. There are 3 different types of resources, A, B, and C. There are 3 types of resources, A, B, and C. Suppose A is hard disk, B is tape drive, C is memory, something like that. So there are 3 different types of resources are there, and the total number of resources is also given. There are 10 number of A, 5 number of B, and 7 number of C are available. Is it understood? This is given in the question that there are 5 processes, 3 resources. Of how many number of resources are there? 10 number of A, 5 number of B, and 7 number of C are there. At a particular time, this snapshot is given. The snapshot at time 0 is given over here. This is the snapshot given, correct? This is the snapshot given. Now, to check that whether it is in safe state or not, the system is in safe state or not, we have to check it. Understood? So question will come that this is given, this scenario will be given, whether first point will be whether it is in safe state or not. If it is in safe state, what is the safe sequence? Whether it is in safe state or not, if it is in safe state, what is the safe sequence? Correct? So let us solve the problem now. Let us solve over here itself. So you will be given with this only, max, allocation, and available. This up to this we have given. You have given in the question with these values. Correct? So that means there are 3 types of resources. Now currently available is 332. There are total 3 number of A, 3 number of B, and 2 number of C are there. These are being allocated. Just see over here. How many A are allocated? Total, how many A are allocated? See over here, 3 plus 2, 5, 5 plus 2, 7. 7 are allocated, 3 left. So total 10 instances of A are there or not? B. 2B are allocated, 1, 2, 2B and 3 are available. So 5 number of B are there. So total this matches. C, how many C are there? 2 plus 1 plus 2, 5 number of C are allocated. 2 are available, 5 plus 2, 7. So even if these are not given, you can compute. If any one of these two are not given, suppose this available is also not given, you can subtract it from here and get it this available. Can you get or not? Hello, are you getting me?
Yes, sir.
Okay. So what you will do? Add all A, what are allocated? 3 plus 2 plus 3 plus 2, 5, 5 plus 2, 7. If 10 is given, so 10 minus 7 is 3 over here. 1 plus 1, 2, 2, 5 minus 2 is 3, is over here. 2 plus 1, 3 plus 2, 5. So 7 minus 5, 2. So I can get the available. See, so if any one of these two is not given, we can compute from here. Now this is computed. So what you'll do, you will find the need matrix. You will find the need matrix. What is need? Need is max minus allocation. Need is max minus allocation. That we have, I have told you in the previous slide. Correct? So you just do it over here. Max minus allocation you do and check. Correspondingly we will do. Correspondingly we will subtract. Anyway, this is max minus allocation. Okay. So what do you have? Max, this is max. So 7 minus 0, 7, 5 minus 1, 4, 3 minus 0, 3. Is it understood? So correspondingly, we will subtract the, from max, we will subtract the allocation and we will get this matrix. Need matrix we will get. Correct? So two things we can compute of our own. This one we can compute if the total number is given, and we can compute the need matrix. Up to this, can you do or not? Can you compute the need matrix? Simply max minus allocation. Correspondingly, each value subtract. There might be A, B, C, D given. So all the 4 values you will subtract, and here you will write A, B, C, D and all the 4 values. Is that clear? Hello?
Yes.
Okay. So now what to do? See, this number of resources are now available with me. Right? I have 3 number of A, 3 number of B, and 2 number of C are available with me. Now I will go on checking that with these available resources, can I satisfy any of these resources? These processes are being currently allocated with some resource, and they are requesting, they require this number of resources currently. So what does it mean? They are maximum for every process. They have declared that what is the maximum requirement. Currently they are allocated with some resources. So what is their need? We have computed by writing max minus allocation. Now suppose my currently I have available with 332. With 332, can I satisfy P1, P0? With the available resource of 332, can I satisfy P0? P0, what need is how much? 743. I have 332. Can I satisfy? P0 requirement need is 3743. Available is 332. Can we satisfy P0 requirement? Hello?
No, sir.
Yes.
No. So can we satisfy for P1? P1 is 122. I have 332. Can I satisfy or not?
Yes, sir.
So I can satisfy for P1. I am just writing over here. I have write P1 is being selected, suppose. So for P1, I will allocate this. If I allocate this, what will happen? I have told you earlier, suppose 10 lakh rupees you have taken loan. You have demanded 10 lakh. 5 lakh is being allocated presently. If the next 5 lakh will be given to you, how much you will return then? You have to return all 10 lakhs. That means what he has taken earlier, those also it will return. Along with this, it will also return this or not. So if we allocate it, it will definitely finish and return this. So therefore, once P1 will finish, I will get this resource. I will get this resource 200 I will get. So now I have 5, 5, 3, 2. 5 number of A, 3 number of B, and 2 number of C are there. Now this is available with me. So P1 has finished. Now with this 5, 3, 2, can I satisfy P0? No, I cannot satisfy P0. Can I satisfy P3? No, this is requirement 6. I have 5, so I cannot satisfy. Can I satisfy 0, 1, 1? Yes, I can satisfy this one. 0, 1, 1, I can satisfy. Right? So I'll select P3, suppose. Suppose I select P3. Correct? So once P3, I'll allocate this resource to P3. P3 will definitely return this resource. Whatever he has previously allocated, that it will return. So it will return 211. So it will return 211. And this is how much now with me? 7, 4, and 3. I have 7, 4, and 3. Now I'll see with this 7, 4, 3, can I satisfy any of these? Can I satisfy P1, P0? Yes, I can satisfy P0. 7, 4, 3 is requirement. I am having 7, 4, 3. So I can satisfy P0. So I add it over here. I add it over here. Correct? P0. Once P0 is satisfied, P0 allocation, that is 0, 1, 0, it will return. So that means this 0, 1, 0, this 0, 1, 0 will be added, so that I will have 7, 5, and I will have 7, 5, and 3. Correct? Now I'll check with this 7, 5, and 3. Can I satisfy any other process from the beginning? You see, I can satisfy this one also. I can satisfy this. So this is P2. So I select P2 over here. I select P2. And what is the value? It has already allocated. For P2, it is 302. For P2, it is 302. So you add 302 over here. You add 302. So how much we have? This is 10, 5, and 5. 10, 5, and 5. Correct? With this 10, 5, and 5, I can allocate the P4. So I can give it to P4. P4. So it will return 002. So that will return 002, and which result in 10, 5, and 7. Now look into this 10, 5, and 7. This matches our initial available resources or not. So after allocating, the bank get all its money back. So the processor allocates some resources. After completion of all the processes, it got all its resources back. And you will see that we could able to satisfy all the processes. We could able to satisfy all the processes, and all processes can execute. if you able to get satisfy all the processes, then we say it is in safe state. Try to understand. You will solve it, and if you found that each of these processes can be satisfied with the available resources, then we will say it is in safe state. And what is the safe sequence? Safe sequence is this one. This is the safe sequence: P1, P3, P0, P2, P4. So not necessary that this is the only safe sequence. This is not the only safe sequence. Suppose I have available with 743. Instead of giving to P0, I would have given to some other process. So I may give it to any process which it can satisfy. Correct? So safe sequence may not be unique. So for different people, in the safe sequence may be different. How it is different? Because once I have some resource, whoever the process is fulfilling, I can give it. It is always better to search from the beginning. Always you search from the beginning and allocate. That will be easier for you to do. But this is not the rule actually. You find any process whose need is less than your available, so that you can allocate it. Is that understood? So we got two things over here. First, whether it is in safe state or not. Second one is we are finding the safe sequence. And one thing you remember, if any one of the process, if any one of the process cannot be satisfied, then it is not in safe state. If any one of the process cannot, if single process, suppose I have 10 processes and one process, we could not satisfy the need of one process, then also we'll say that it is not in safe state. The working of that, the problem that I have solved over here, this is, I just put it in a slide over here. So this is, there are n is equal to 5 number of processes, 3 number of resources. We have taken n is the process, m is the resources. Now we found that initially it is 332 is given. See, it is 332, and this is the working of that algorithm. Algorithm I have not explained till now. So that the way I have solved, same thing is given over here. The way it is being solved, the algorithm is given in that way. Correct? So let us go to the algorithm now. If you have any doubt in the problem, ask me. Otherwise, you will go for the algorithm. You have understood the process. Now, same thing is being written in the algorithm. I will explain you how the algorithm works. If you have any doubt on this problem, you may ask me. Okay. So,
the sequence need to be, we can use in place of P0, we can use P4 first.
Yes, that can be. I said already that you can use any sequence. I have used from top to bottom. You can use any sequence. Now, in any sequence means whoever is satisfied, not necessary to be sequence even. You can select P4, then P1. It's up to you only. If it is satisfying, you just allocate it. Not necessary to. So you may have a you may not have a unique sequence. Like here I have solved and I got it P1, P3, P0, P2, P4. But in this slide earlier I have computed to be P1, P3, P4, P2, P0. There is another sequence. Okay. So what we are doing over here, the same thing is being in this resource request algorithm. The resource request algorithm checks and determines if any request I can be safely granted or not. That means if I want to grant the resource, whether it will be in safe state or not, the meaning is safe. So what we will do? Request of I means request vector for process Pi. Request of j is equal to k means process Pi wants k number of instances. Okay. Now see, before allocating, what will check if request is less than need or not. We are computing this need. We have suppose 753 is the maximum. It has currently allocated 010. So what is its need? Its need is 743. Can the process demand more than its need? If the process demands more than need, that means it is error. The max it has already declared. What is the max it has already declared? Out of that, some are allocated. So these are left. So process must demand or request any value between this. It cannot exceed this value. If it demands which exceeds this value, then it is an error. So it says it will check that whether request is less than need or not. If request is less than need, then go to step 2. That means we will go to here. We will go to step 2. But if request is not less than need, that means request is more than need. That means it's a raise error condition. Because the process has exceeded its maximum claim. It has earlier declared 5. Now it is demanding more than that. That means it is an error. It's an error. Correct? So first thing we must check that request must be less than need. Suppose request is less than need. Then we will check that whether request is less than available or not. Because suppose this is, we are available with 332. So 332, so first we'll say that, see that this 332 is less than this value or not. So that means whether request is less than the available or whatever it is requesting, that number of is available or not. Correct? It is requesting 743. I have available with 332. Can it be given? No. It is requesting 122. It is requesting 122. And I have available 332. Then I can give. So the request must be less than available. So two things we will check. Whether request is less than need or not. If it is less than need, whether it is available or not, whether request is available or not. If it is available, we will go to step 3. If it is available, we will go to step 3. And if it is not available, then what it has to do? It has to wait. If it is not available, the PI must wait. Since resources are not available, it has to wait. Its turn will come. But in the previous case, if it is less than need, request is less than need, request is greater than need, then it is an error. If request is greater than available, then it has to wait. Now see over here. Now suppose both of these conditions are satisfied. The condition 1, condition 2 is satisfied. The request is greater, the request is less than need, and request is also less than available. So we have the scope is there to allocate. We'll pretend, means we'll assume that resource is allocated. We'll not actually allocate. We'll assume that it is allocated. And what we'll do? We'll do this. Available equals to available minus request. Whatever it is requesting, we'll subtract it from the available. We are assuming that it is given. That means allocation plus request. Try to understand. We'll assume that request has been given. So from the available, we'll subtract it. Whatever available, we'll subtract. And like this one, we have available 332. It is demanding 122. We'll assume that we have given. So available equals to available minus request, and allocation is equal to allocation plus request. So we have taken from the available and allocate it. Available equals to available minus request means from the available we have taken. Allocation is equal to allocation plus request means that we have given to allocation. Once we give allocate it, my need will also change. My need will change. So need is equal to need minus request, because we have allocated, my need will reduce. So need is equal to need minus request. Correct? So what I am doing? Subtracting my request from the available, allocating that to the allocation plus request, and my need should change. Therefore, need is equal to need minus request. And now I will check whether it is in safe state or not. If it is in safe state, we will allocate. If it is not in safe state, we will not allocate. How will you check that it is in safe state? If all processes have satisfied, then we will say is in safe state. If any one of these process, any one of the process cannot be satisfied, then we say it is in unsafe state. Correct? So how to check that it is in safe state? So therefore, to check that whether it is in safe state or not, we have another algorithm is called safety algorithm. We have another algorithm is called safety algorithm. So Banker's algorithm has two parts. First part is the resource request algorithm. So we'll assume that, so we'll check that request less than need, request that less than available. We'll assume that it is given. So we'll update the available, allocation and need. Now we'll check that whether it is in safe state or not. How do you check? What we are doing over here for checking it is in safe state or not? We initially it is not being given to anyone. So suppose initially all are false. So we select a process whose value is false, and this is the need is less than this available. We allocate it, right? So see over here what we have done. So because we are doing temporary changes to the variable, so we are not, instead of changing the available, we store it in another variable work. Why you to store it in work? Because I want to change on work. I don't want to change on available, because this is the original one. I put it in a work and I will change over here, because I am doing a temporary operation. If I found that all satisfied, then I may have a changes over here. So now I'll see that whether all can be satisfied or not. Initially, all are false. That means I'll have a matrix like this for P1, for P0, P1, P2, P3, P4, P5. For every P0, P1, P2, P3, P4, up to this, sorry, up to this. These are processes. And for every process, initially it is false. That means all has not been satisfied. They have some need. Those processes having some need will be put over here. Correct? Finish of I equals to false for I is equal to 0 to n minus 1. For every process, we will make it false first. Now what I'll do, I'll select a process. I'll find an I such that finish of I equals to false. Any one process I'll take which process status is false and need is less than available. Need is less than work. Work is nothing but the available. So need is less than available. So see over here, 743 is less than 332. No, it is false, but it is not true. 122 is less than 332. Yes, and it is false. So that means I found a process. This is not the only process. There might be this process is also there. P3 is also there, which is less than this 332. I could have selected P3. So I will select any I whose finish is false and need is less than available. Need is less than work. So once I select, what I do? I'll add its allocation to the available. I am adding its allocation to the available. So look over here, work is equal to work plus allocation. Work is nothing but the available. So work is equal to work plus allocation. That means this is satisfied. P1 I have satisfied. Once P1 is satisfied, I'll change it to, instead of true, a false, I'll make it true. So now go to step 2. Go to step 2 means I will find another process whose finish is false and need less than available. So if I get it, suppose I get P3 like that, then I will make P3, then I will make P3 true. Right? So I'll go on repeating the same thing. And if I found all true, if I found that all are true, that means we could able to satisfy all the processes. We could able to satisfy all the processes. Understood? And we say it is in safe state. Then we say it is in safe state. Correct? This is first part of your problem. Another part of your problem is there, that also will discuss that if now a process request for some resource, whether it will be allocated or not. Understood? Is the first part understood up to this? Is it understood? So the second part we'll discuss in the next class.